No, just give me one moment, Katie. I'm starting a video. One second. All right, sorry for the delay there. A little bit of mic issues. So this video is going to be on using similar solids and similar properties to solve for different segments or different measurements. So just make sure my mic is actually working here. Yeah, okay, good. So last video we talked about how to identify similar solids, solids being kind of the mathy way of saying a 3D object. So just recall that two objects are similar if all their corresponding pieces have the same scale factor, which is, again, the scale factor is the value that you multiply or divide by to go from one object to another. Come on, stay there. So let's take a look at these triangular prisms here. So I want to figure out which one of these are similar. If they're all similar, if none of them are similar, if only two of them are similar, which ones are similar? So usually when you have these types of problems, it's best to pick at least one to kind of be your core one that you're going to check against. So let's pick this one as my given shape. So I'm going to check to see if any of these are similar to this shape here. And if they are, great. If not, then I'll check to see if these are similar to each other. And if that's not true, then none of them are similar. So let's start with saying we'll call this shape A, we'll call this shape B, and we'll call this shape C. So let's start by comparing A to B. So A to B. Let's start by comparing those two. So that means if I take this 4 line here, so 4 is part for A, that means it should correspond with this 5 line over here because it's going the same direction. They're both the sides of the triangle essentially. And then the 10, the bottom line here, should correspond with 12.5, which is the bottom line there. So 10 over 12.5. And then the 3, which is the height of the triangle, should correspond with the 3.75 over here. So 3 over 3.75. That's a 3. I don't know why it got thicker all of a sudden again. And then lastly, this 6 right here should correspond with this 7.5 over here. So 6 over 7.5. And again, if you hear a beep or something, that just means my mic cut out, so I'll just have to put it back on again. So if that happens, just give me 2 seconds. So if I want to check if they're similar, that means I need to divide the top and the bottom numbers by each other. And if I get the same decimal in all of them, then they're similar. I could also reduce the fractions, but because I don't want to work with decimals inside fractions and all that mess there, I find it easier just to get the decimal by dividing. So let's check here. 4 divided by 5 is 0.8. 10 divided by 12.5 is also 0.8, so we're good so far. 3 divided by 3.75, 0.8, we're good so far. 6 divided by 7.5, 0.8. Right, so these are all of these divide out to being 0.8, which means that they're similar. Because all the unit fractions, sorry, not all the unit fractions, all the scale factor fractions agree. If just one of these was off by a little bit, like if one of them was 0.75 or something like that, then they would not be similar. So I know that shape A and shape B are similar, which if you don't remember, the notation for similar is shape A is similar to shape B. It's written like that. The little squiggly here means similar. Well, what about A and C? So let's try check A and C. Because if A and C are similar, that means that B and C would also be similar as well. So if these match, then these would match. If these don't match, then these aren't going to match either. So I can just check A and C, and that will also check the last setup for me as well. So let's see. Shape A here, we'll do 4 and 3. So 4 and 3 because they're both the sides of the triangle. 10 and 7.5. So 10 and 7.5. And then 3 and 2.25. So 3 and 2.25. And then 6 and 4.5. So 6 over 4.5. So let's check to see if these come out. So 4 divided by 3 is 1.3 repeating. Okay. 10 divided by 7.5. Good so far. 3 divided by 2.25. Good so far. 6 divided by 4.5. Good so far. So yeah, these would also be similar. So everything here is 1.3 repeating. So A would also be similar to C because all the fractions come out to be even. And then also that means that A, C, and B are all similar to each other. So A is similar to B. A is similar to C, which again, by transitive, because similarities are transitive, that means B is also similar to C as well. So if A is similar to B and A is similar to C, that means these two are similar to each other as well. So I don't necessarily need to go back and check them again, because that will already do it for me. So all three of these shapes are similar to each other. Different scale factors for each. So this is a scale factor of 0.8. This is a scale factor of 1.3 repeating, because A is bigger than C. But they are all similar to each other. So how do we use this fact to solve for different segments? Well, the main thing here is when you have two similar shapes and you want to solve for a missing segment, you have to find your scale factor first. That's going to be the key to solving all your problems. So let's say you have two pyramids here, two triangular pyramids, right triangle on bottom, point on top, and I want to solve for x and y. Well, in order to solve for x and y, I first need to get a scale factor to go between these two pyramids. And it doesn't matter which order I do them in. So let's, again, call this pyramid A, and we'll call this pyramid B. So let's say I want to set my scale factor as, well, let me pick out what numbers I can use first. So could I use 15? Well, no, because 15 is this dotted line right here. That would match up with this y number right here, but I don't know what y is. So if I say my scale factor is 15 over y, that's not going to help me because I don't know what y is, and I can't really use that scale factor fraction anymore because it's not going to help me solve. What about this 22.5 down here? Well, again, that's not going to help me because 22.5 is this bottom line here. That's going to match up with this bottom line here. And again, I have a variable in my scale factor. So you do not want a variable in your scale factor. You want a scale factor that's nice and complete with numbers, which leaves only 12 and 30. So I'm going to have 12 over 30 as my scale factor, which if we reduce it, well, I can't talk, which you can reduce before you go on with the problem. So let's reduce this here. So 12 divided by 2 is 6, 30 divided by 2 is 15, and then 6 divided by 3 is 2, 15 divided by 3 is 5. So this would be the scale factor I would use in starting all my problems. And again, I'm going to note here that it was A on top and B on bottom because your fractions have to be consistent. So A's number on top, B's numbers on bottom. So let's say I want to solve for x then. Well, I start with my scale factor, 2 over 5. And then I'm going to figure out, okay, what number over here would pair with x? Well, x is this bottom line here. 22.5 would be the bottom line there. Those would be the two that get paired. So it would be, now again, this is A over B. So this also has to be A over B. So that'd be x, which is part of the A shape, over 22.5, which is part of the B shape. And then I can go ahead and do my cross multiplication. So 5x is equal to, what would that be, 45, right? 22.5 times 2 would end up giving you 45. And then you divide by 5, and you get x is equal to 9. That'd be how you'd solve for x. Again, you pick out your scale factor fraction, reduce it if you can, and then set up another fraction that you can cross multiply with. And to get y is the same thing. If you want to get y, what you would do is you would set it up as 2 over 5 first, is equal to, and you have to find out, okay, what number over here pairs with y? Well, if y is this diagonal line here, that's going to pair up with 15, which is, again, the same direction. So once more, it has to be A over B, though. That has to be consistent. So I'm not going to write y over 15. I'm going to write 15, which is in the y, which is in the A shape, over y, which is in the B shape. So again, A over B. And once you pick an orientation, once you pick a style, you have to stick with that the entire problem. So cross, that'd be 75 is equal to 2y. Divide by 2. And you get y is equal to 75 divided by 2 is 37.5. So that would be how big y values is. So once again, all you have to do is get that scale factor first. And the way you get that scale factor is you pick a segment over here, you pick a segment on the other shape, see if you get two numbers that can correspond and make a fraction. Once you have that fraction, it's just a matter of using that in your setup first thing every time. It's all cross multiplication, all proportions. Now, what you'll be asked to do is you're going to be asked to do this for not just linear segments, but also areas and volumes. And luckily, it doesn't really change that much. So if you want to find the missing linear segment, which is a length, a height, a width, a perimeter, all those you do what we just did. So this is the example of finding a linear segment, because these are all linear segments. If I gave you the perimeter of this shape, I could ask you what the perimeter of that shape is, and you do the same exact thing. A over B, and cross multiply. Now, if you want to find a square unit, which is like an area or surface area, what you have to do is square the scale factor first before you go ahead and cross multiply. So if I asked you, okay, find the surface area of this prism given that the surface area of this prism is 20. Well, you would square the scale factor fraction first and then set it up like we did before. A area over B area is equal to the square of the scale factor and then cross multiply. And then for volume, which is a cubic unit, again, volume's like meters cubed, feet cubed, inches cubed, you'd have to cube the scale factor first before you cross multiply. So let's take a look at an example problem that deals with all three of these, okay? And we'll take a cylinder just because we haven't really done non-polygons or non-polyhedron for a while here. So we have two cylinders. We're going to assume that they're similar. So this one is 9 meters long, or 9 meters as a radius. This is 12 meters as a radius. We want to find the height of cylinder A given that the height of cylinder B is 27. So we're going to assume, at least in this problem, that the height here is 27. We want to find out how high cylinder A would be. Well, if they're similar, that means their scale. I need a scale factor here. Well, the only two numbers I have are 9 and 12. So I might as well use those, and luckily they are both radii. They're both the radius of their respective cylinders, so they do match up. They're corresponding. Yes, 9 is the top radius and 12 is the bottom radius, but because both circles are congruent, it's also 12 up here. So 12 up here, 12 down here, 9 up here, 9 down here. Whether you have the top and bottom radius, they're both going to be the same. So this radius and this radius are corresponding because they're both radius. And so those will be my scale factor. I'm going to put A over B again. So A over B, which is going to be 9 over 12, which if I divide by 3 would give me 3 over 4. So this is my scale factor for this problem here. So I do 3 over 4 is equal to, again, I want A over B. That's the setup I'm working with here. Well, if I'm looking for a height, that's a linear measurement. Height is a linear one-dimensional measurement. Height is not measured in meters squared or meters cubed. Height is simply measured in meters, what we call linear units. No squaring, no cubing. So I can just set up like I did before. I put the height of cylinder A, which I don't know, so that'd be x, over the height of cylinder B, which they tell me over here is 27. And then I can go ahead and do my cross multiplication solution. So height is just the same way as length, width, perimeter. All just means take your scale factor, set up your second proportion, or set up your second fraction, and cross multiply the proportion. So this would end up giving me 4x is equal to, let's see, 3 times 7 is 21, carry the 2, 6, 7, 8, 8. So it'd be 81. Yeah. So divide that by 4, and you get x is equal to, let's see here, 81 divided by 4 is 20.25. So 20.25. And that would be in meters. So this is just like the last problem we did, except that now we had to compare their radius as my scale factor rather than the length or the width or something like that. But again, as long as the pieces are corresponding, you can use it to be a scale factor. Again, corresponding means they do the same thing on each shape. So 9 is a radius on this shape, 12 is a radius on that shape. They're both radius, they both correspond, so I can use them as a scale factor. If I didn't know this and I said that this was 12 instead, then I'd have a problem because I can't match up a radius with a height. Those don't correspond because one measures the radius, one measures the height. They both have to be the same type of measurement. So the next one here says find the surface area of B if the surface area of A is 2200 meters squared. Well, if I'm dealing with the same cylinders, that means I can use the same scale factor. So 3 over 4 still. But if it's area, before I set up my fraction, I'm going to have to square this part here. So if it's area, you square the scale factor first, and then you set it equal to your area fraction. And again, I'm still going with A over B here. So the surface area of A is 2200, so 2200. And the surface area of B is x. So I'd set it up this way. I'd have to square this fraction first and then cross multiply. So 3 squared is 9, 4 squared is 16, is equal to 2200 over x. And then now I can go ahead and cross multiply. So all that's changed here is you square first and then cross. So 9x is equal to 2200 times 16, which is 35200. 200. Making sure my mic is still working. It is good. So divide by 9, and I get divide by 9, 3,911.1 repeating. So 3,911.1 repeating is equal to x, which would be, in units here, 3,911.1 repeating meters squared. Again, you know you have to square the scale factor if your answer is going to be in square units, which is a good, again, incentive to make sure you remember what units to put down. And we're back. Good. Okay. Like I said, my mic for some reason cuts off every now and then, so you have to bear with that here. So again, as I was saying there, if you remember what kind of units to put in your answer, you'll remember what kind of process to do. So if you have square units, you have to square your scale factor fraction. If you don't have any units, like if you just, well, I shouldn't say any. If you don't have any square or cube units, you just keep your scale factor fraction as it is, like we did in the first set. And again, this kind of makes sense because shape B obviously is bigger than shape A. It's the bigger similar one. So its surface area should be more than shape A. So it's good that this surface area is more than what I started with because that implies that shape B is bigger than shape A, which we know it is. If this was smaller, then I have to go back and check my work. So last one here says find the volume of shape A if the volume of shape B is 12,200. Well, again, stick with the same scale factor, 3 over 4. But because it's volume and because it's cubic units, I'm going to have to cube this fraction first and then set it equal to my other fraction. And again, I'm still going with A over B. So the volume of A, I don't know. The volume of B, however, I do know, 12,200. 12,200. So that would be 9 over 4 cubed, which is 16 times 4, which would be, come on, 16 times 4, because 16 is 4 squared, that'd be 64. So 4 cubed is 64, is equal to x over 1200. X over 1200. And then you go ahead and you cross multiply. So 64x is equal to, and then 9 times 12,200. And we get 109,800. So 109,800. And then the coup de grace here, you divide by 64. So divide by 64. And you get 1715.625. So x is equal to 1715.625 meters cubed. Making sure I check my answer on that. Right. And again, this makes sense because the volume of shape A should be less than the volume of shape B because A should be smaller than B. So it's good that its volume is less. And that is how we get the volume version. So if you notice here, all three types of problems start out the same way. Get your scale factor, write it out first thing. All it is scale factor equals other fraction. Now, if it's a linear measurement, that's all you do. If it's an area measurement or a square unit, that means you square your scale factor first before you cross. And then if it's volume, you cube your scale factor first before you cross. And it's always the scale factor that gets cubed. Now, why is it the scale factor that gets cubed or squared and not the other fraction? Well, because think about what this fraction is. 3/4 is literally 3 meters over 4 meters, which basically says for every 3 meters on shape A, you have 4 meters on shape B. That's what this literally means in English terms. Every 3 meters on shape A is 4 meters on shape B. But my areas are in square units. Like if I go back up to this one, my area is 2,200 meters squared over x meters squared. So I can't really cross these because these units don't agree. Neither way, no way I can do this can I get the units to agree. So that's why I have to square this fraction first, because when I square it, I get the result that 9 meters squared in shape A for every 16 meters squared in shape B. And then I can go ahead and cross multiply here. So that's why I had to square, or if it was volume, I had to cube the scale factor fraction, because this is already in square units. So this is the one I have to square to get it back. Alternatively, some of you might be saying here, alternatively, you could do this. You could say 3 over 4. You could get your area fraction over here, 2200 over x. And instead of squaring this, you could square root this, or if you're doing volume, you could cube root that fraction instead, and then do it that way. So this usually is easier because people normally know how to do squaring and cubing more than rooting and cube rooting. So that is an alternative method if you want to investigate that way, but usually this method is going to be the easier one to comprehend. So that's it for this video. Again, pretty short one, all things considered. And it's very simple procedure for all three cases. There's just a slight twist in each one. So just make sure you read the question carefully and know what kind of units you're going to be going through. Hopefully this video helped you out. Have a good day. There it is. Yeah.